Did you do your homework? I hope so. So let's take a look at my solution to the problem of taking a look at how conditional probability tells us about whether there's a relationship between age and purchase probability in a fake data set. Let's go. Okay, let me walk you through my solution here, and this should be pretty straightforward. Again, the objective here was to remove the dependency between your age and your likelihood of purchasing and see if you can actually tease out of the math that dependency, that conditionality, went away. So if you recall from our walkthrough of this code that generates our data set, we used to have a line here on purchase probability that generated that based on your age. It basically took your age decade and divided it by 100 to create that condition between your age and how likely you are to purchase something. So what I've done here instead is just hard-coded that to 40%. So there's no longer any relationship between your age and your likelihood of purchasing something. So let's go ahead and regenerate that data set, removing that dependency between age and purchase probability. So now we can compute P of E given F again. Again, that's the probability of making a purchase given your age. For some age group, we'll pick 30-year-olds again just to be consistent. So again, we'll compute the total number of purchases by 30-year-olds by the total number of 30-year-olds, and we end up with the number about 40%. And we can independently compute P of E, which is just the probability of purchasing something overall regardless of your age. That comes out to 40%. So 39.8, 40.0, pretty darn close, okay? So in this case, P of E is roughly equivalent to P of E given F. A little bit different just because of random variation, but it's close enough that we can say that E and F are likely independent variables in this case. So the math told us that P of E given F is the same as P of E, more or less. And sure enough, that does reflect the fact that we removed that tie between age and purchase probability. So I hope you were able to reach the same result and learn a little bit of something along the way about conditional probability and how to tease those dependencies between your various features of your data set out of the math. Okay, hopefully you arrived at a similar solution on your own. If not, go back and study my solution. It's right there in the data files for this course if you need to open it up and study it and play around with it. And with that behind us, let's move on to Bayes' theorem.